This is Butterbot, the version 3 video 2. Today we're going to be talking about bevels, specifically bevels in the base. Now, as I said before, the motor I'm going to be using for the base is a lot longer than the stepper motor, which means that I can't put it this way anymore. I need to put it sideways, which means I'm going to be using bevels. Now, a bevel is a special kind of gear where the teeth are at a 45-degree angle as opposed to just flat on the side, and they connect to another bevel gear also at a 45-degree angle, so you can do power transfer at 90 degrees. This means two things. One, I now have to design a gearbox, which is what I was very much trying to avoid. Luckily, it's not any kind of torque increase or anything. It's just power transfer, which should be fine. But two, I now have to do the horrible task, worse than death, that is gear mesh design. And more on how that messed up later. Some more context, though. I've already done this, as you can see, but when I started doing this, I didn't know anything about bevel design, and now that I've completed it, I still know nothing about bevel design. I know what they looked like, I knew what they were supposed to do at the end, but everything in between, who knows? And instead of looking up, hey, how do you design bevels, I just went for it, and it worked out. Okay. It doesn't not work, but it doesn't work. They have an issue that shouldn't be an issue. The bevels connect at 90 degrees, but they are offset by 12 millimeters. I don't know why they do this. I don't know what I did that could possibly cause that. But rather than try to figure out at all why that was the case, I made this hole 12 millimeters offset from this hole. So whatever works, works. It seems to be fine. Now let's, for the next pieces, we'll be moving over to CAD. Alright, so this is the Butterbot base motor casing. This is going to hold the motor that connects axially to the bottom bevel gear. This is what's horizontal with reference to the ground. A few simple parts of this. This is the diameter of the motor. It just slides in. There's a little bend over here so you could push down and snap it on. It'll cover it and hold it in place. But for a real secure connection, these motors have M3 threads. That's a metric 3mm thread going through the face of the motor where the axis comes out. So these two holes will work as washers where bolts will screw through these and hold the motor in place here. These two holes will fit heat set inserts, and if you don't remember what those are, they are basically threads that you can push into printed parts or any kind of plastic, really, with a soldering iron. The diameter here is 4.6. Yeah, 4.6 millimeters. That's what you need to do it. You push it in through there and it holds on the place with some heat. All right. Now for the most important part, oddly enough, is how big this is. Had the distance from this face to this face, which is 26 millimeters, was the most difficult to ascertain and is the most important. That right there, this seemingly arbitrary size, is how we make sure the motor meshes. Because if I just did the faceplate and just suspended it, any kind of torsion on this point or any other point in the motor would have the bevel gears unmesh from one another. And that is an issue with mesh design, which is why I didn't want to do this. So this bottom length needs to be equal to the base length. So not only does this screw into the base, but this is actually touching the bottom, so there's no deflection, no torque on the motor. That isn't the gear moving, you know? So yeah, that's that part. Let's move on to the next. Let's talk about the actual gearbox or the base itself. So this red part is going to be, I'm going to call it the base, but it is functionally the gearbox. Here we can see how that's flat, how that's flush here, and it holds level. Here we can see the D-shaft connection that will connect the bevel gear to the motor. We can see how the motors are going to mesh here. We can see this 12 millimeter offset. If you're curious about why I left this spacing here, that is a mesh tolerance. The actual mesh tolerance of these bevel gears that I designed is about 2.2 millimeters, which is, if you don't know, a layer size in a 3D printer. That is intentional. The reason I have this distance left here is because this is not going to be flush against this. It's going to be some sort of distance off. And this piece here is going to be able to move in this section. So there's going to be some sort of distance offset for the bolt heads that connect to the face of the motor here that will constrain this distance, so we can really control that mesh control that mesh tolerance and the mesh distance in assembly rather than having it constrained by design. Now let's talk about this piece. Now this piece probably doesn't seem like anything special, nothing unique. If we tab it out, you know, it just sits on top of there. It's no anything. It's not helpful. But this piece is the biggest mistake that I made, and also the most important piece that there is. I called this the gear spacer, but it's so much more than that. Let's go through it. This right here is a counterbore hole. A bolt is going to stick straight in there, and it's going to go all the way through. And if you look back on how this attaches, there's going to be a heat set insert here, and it's just going to screw onto the top of that. So it's just adding height so it can meet this distance here. And then these 4 holes will have heat set inserts so that I can fit any kind of shape I want into there. It just needs to have 4. It has access to 4 holes. You don't have to use all of them. You can use 3, you can use 2, you can use 1, you can use none even, although that wouldn't get you much. But this right here is my replacement for a bearing. Any kind of thrust bearing that would go here. It just sits in here and it has this space to work with however I want to be. But this issue that I've caused myself is that now this gear is attached in the same direction of rotation with a bolt. I'll let you think on that for a second to see if you can figure out why that's such an issue. I certainly couldn't when I made it. Did you figure it out? So, because it's put in with a bolt with a heat set insert, when this gear turns left, it unscrews itself. Which is a big problem, because when you unscrew it all the way, you no longer have a gear mesh. Now you have a piece just free floating anywhere and everywhere inside of a box with no bottom. It doesn't work anymore. So my solution to that is we're only going to turn right. We're not going to go left. We're only going to go right. It's not going to unscrew itself because we're not going to turn left. Is this a permanent solution? No. Is it the solution I'm going with until I think of a permanent solution? Yes. Well, and from there we printed everything and we have the full thing assembled. And we will go over very briefly